Look at the wheels on a car, the lenses inside a telescope, or the ring on your finger. We navigate our entire lives trusting in perfectly round objects, but they do not actually exist. In the physical world, they are just astonishingly accurate approximations. This diagram shows a true Euclidean circle. Mathematically, it is a beautifully simple set of points, all exactly equidistant from a central hub. In this idealized abstract world, the curve is infinitely smooth, continuous, and exact. But the moment you try to pull that ideal out of the math and into reality, you hit a numerical wall called pi. Because pi is an irrational number, its decimal expansion continues infinitely without ever repeating or resolving itself. You cannot encode an infinitely precise number into a physical object. There is no ruler, no machine, and no material capable of capturing a measurement that never ends. Physical matter is finite. The very act of trying to construct a flawless mathematical shape out of limited material is mathematically doomed from the start. Every supposedly round object we have ever manufactured is haunted by a number that refuses to resolve. To see exactly where this physical construction breaks down, we have to look past what the human eye can see and zoom in on the microscopic structure of reality. For thousands of years, humans have tried to beat this mathematical limit, pushing science and engineering to pursue absolute geometric precision. In the past, engineers relied on intense manual labor to polish and refine circular components. They measured, cut, and sanded metal down to tolerances that barely registered on their physical instruments. Fast forward to modern engineering, and you get objects like this. These incredibly reflective spheres were created for the Gravity Probe B experiment, representing some of the most perfectly smooth items humanity has ever forged. It took advanced nanotechnology, extreme polishing, and decades of research to manufacture these spheres so they could test the physics of relativity in orbit. Yet, when scientists measured these near-perfect spheres under high magnification, they still found microscopic deviations. The material was not completely uniform. At the macroscopic scale, our best tools can only polish materials to create a highly convincing illusion of smoothness. The limitation isn't our machinery, it is the physical matter we are building with. If we zoom past the polished surface of that sphere and go straight into the material itself, the illusion shatters. Look at this model showing an object's structural boundary. Matter is not continuous. It is built from individual atoms connected by molecular bonds. When you scale up what appears to be a curved surface, you find it is actually constructed from tiny linear arrangements. A true curve is impossible here. Every edge is actually a jagged atomic staircase. Even if you could somehow arrange those atoms into a perfect ring, physics introduces an insurmountable obstacle: heat. Because absolute zero temperature is unreachable in modern thermodynamics, atoms are never entirely still. They possess thermal energy, which causes a constant vibration known as atomic jitter. Heat forces the material to constantly expand, contract, and distort. A physical circle exists in a state of perpetual microscopic deformation, warping its radius second by second. If we drop even deeper, far past the atoms, we reach the ultimate bottom of reality, a scale of around 1.6 times 10 to the negative 35th meters, known as the Planck length. At this extreme magnification, our everyday ideas about continuous space, distance, and shape completely dissolve. There are no surfaces left to measure. Physicists suggest that down here, space-time itself behaves like a quantum foam. It becomes a granular, chaotic environment where conventional geometry breaks apart into shifting, probabilistic structures. At these scales, the architecture of the universe itself forbids the existence of infinitely smooth curves. When we pull all the way back out to the human scale, the physical objects around us start to look a little different. The smoothness of a wheel or a polished ring is an emergent illusion. It only looks round because our human senses are too blunt to perceive the jagged, vibrating reality underneath. Mathematics operates in an idealized world of infinite precision, while the physical universe is messy, granular, and forever in motion. Our inability to reach perfection is not a failure of engineering, it is the mechanism of our growth. Engineers build smoother bearings, and physicists calculate trillions of digits of pi precisely because perfection is always just out of reach. We have built the modern world by constantly trying to close that gap. The perfect circle is a ghost trapped inside mathematics. Yet it is exactly our relentless pursuit of this impossible shape that propels science, engineering, and civilization forward.